This model can faithfully reproduce human kinematics and biomechanics, which facilitated our controller to learn and identify effective control strategies.
Hey everybody, welcome to Studio 64. My name is David. I've been searching the interzones for some more science, space and tech news to share with you. And I came across this over at Popular Science. This should be entertaining. Yes, AI-enabled virtual training could make robotic skeletons more common. I could do with one of those myself, actually. My own skeleton is, how shall I describe it, since my total hip replacement surgery. Ever bought a Terminator off Temu or Wish? That's me, Budget Terminator. Fascinating. Simulations can cut down on time-consuming testing typically performed by humans. Very good. As human testers using the simulation-trained exoskeleton use 24.4% less energy while walking. I could do with a whole lot of that. Make it 124% less, and I'd be signing up for that. Now, in the US alone, the Centers for Disease Control, the CDC, estimates around 12% of the population lives with a mobility disability, making it difficult for them to walk or climb the stairs. Some 1.3 billion people worldwide reportedly face similar challenges. Me. Robotic exoskeletons, sci-fi inspired mechanical support suits, have been heralded by some as one potential solution, but actual access to those devices remains few and far between. Researchers are hoping they can help shrink that accessibility gap thanks to a new AI-enabled testing method they believe could greatly reduce the amount of in-person training time required to make these devices function properly. Very good indeed. Absolutely incredible. And as usual, I'll leave the link to the main article below the video so you can pop in and check out these embedded links if you want to go for a bit of a deeper dive beyond the main article. Just makes for an interesting read for you. Yeah, so exoskeletons, which are sometimes referred to as exosuits, are robotic wearable devices that connect to the outside of a person's body and provide an external mode of aid. That can be delivered by way of small motors or other power sources that add torque and support. When focused around a wearer's hips or legs, these exoskeletons can give the added power and stability needed to aid with mobility. That would be really good, particularly with me, because before my surgery, I'm getting along well now, but before my surgery, it was very difficult for me to, stand up for long. Now I can get around, go out, do stuff. It's just absolutely amazing. Yeah, absolutely amazing. Now, widespread access to exoskeletons is limited, in part because human testers are typically required to train the devices and inform them on how and when to apply pressure to parts of a user's body that need assistance. Now, those contextual cues are crucial to achieving the device's ultimate goal of making it easier for a user to move around, but they can be time and resource intensive. In an effort to reduce those barriers, a group of researchers recently developed a novel technique using AI to train exoskeleton controllers in computer simulations. Well done. Now, the use of simulations for training, the researchers argue in a recent Nature article, dramatically cuts back the need for physical human experiments. Now, in theory, this type of training method could make exoskeleton devices more accessible and ready to use off the shelf for people with limited mobility. Now, North Carolina State University professor and paper co-author Hao Su described the new approach as akin to bridging the gap between simulation and reality. So like AI in general, I'm assuming that the more you used it, the more it'd get used to you, the way you walk, your movements and everything else, and would adapt the exoskeleton to your individual needs. One size fits all type of thing. That would be interesting, as long as the AI didn't take over and walk me off a cliff. If it walked me home safe from the pub, I'd be more entitled, more excited about it. But as I said, as long as the AI is what we call a dumb AI, which means that it only does what it's supposed to do and nothing else, I don't want it attaching to the internet, for God's sake. Bloody hell. That would be a bit of a worry. No, I did not ask you to go to Pornhub, and stop doing that with my body. That would be a real worry, wouldn't it? All right, we've got ourselves a little video here. I think we should check it out, and we'll carry on the conversation when we come out the other side.
Exoskeletons can improve human mobility, but developing exoskeleton controllers requires lengthy human tests and handcrafted control laws. We developed a learning and simulation method that leverages data-driven and physics-informed reinforcement learning to obtain a controller purely from the simulation. Our method consisted of 3 neural networks, namely motion imitation, muscle coordination, and exoskeleton control networks, which were trained simultaneously in a closed-loop manner. To facilitate deployment on a physical robot, our train controller only requires 1 sensor per leg and can be implemented on a portable microcontroller. Our controller only needed to be trained once for 8 hours in the simulation. During this learning process, it gradually learned to generate effective assistance to assist humans with 3 activities. Our method also simultaneously trained a high-fidelity human musculoskeletal model to simulate the human response to the assistance. This model can faithfully reproduce human kinematics and biomechanics, which facilitated our controller to learn and identify effective control strategies. We evaluated the performance of our train controller for walking, running, and stair climbing at different speeds. Metabolic rate was recorded to quantify the energetic benefits the participants obtained from the assistance. Our train controller substantially reduced energy expenditure by 24.3%, 13.1%, and 15.4% during walking, running, and stair climbing compared with no exoskeleton conditions. This is the largest reduction reported in the literature with any hip exoskeletons or any lower limb exoskeletons, either tethered or portable. Our train controller could also produce smooth and continuous assistance for the 3 activities and especially their transitions, without the need for discrete activity classification or gait phase segmentation. The assistance profile exhibited distinct shapes for each activity, highlighting its ability to adapt to the changing requirements of the wearer automatically. This is the first work in wearable robotics to show that it is feasible to formulate an end-to-end controller to synergistically assist multimodal locomotion. We envision that this generalized, simple, and easy-to-use learning method can also be applied to a wide variety of assistive technologies, such as prostheses, to restore mobility of people with disabilities.
Well, that was really interesting. I really liked that. That was absolutely amazing. The key idea here is that embodied AI in a portable exoskeleton is learning how to help people walk, run, or climb in a computer simulation without requiring any experiments to added. Now, the learning in simulation framework developed by the researchers is based on 3 connected, multi-layered AI neural networks. Researchers applied this learning method to a custom-made hip exoskeleton intended to increase walking mobility. Once it was trained in virtual simulation, the researchers then strapped the hip controller to human testers to see how it performed. So that would make sense. Get the AI to understand the basics of human mobility, right? And then once you've got that basis down, just obviously learn from somebody walking, adapt to that individual style. The results were encouraging. Participants wearing the simulation trained the exoskeleton controller used 24.4% less metabolic energy while walking than a control group of people walking without it. Okay. Users wearing the exoskeleton device similarly exerted 13.1 and 15.4% less energy while running and climbing. Running and climbing in respect compared to people performing the same task without the devices on. Yeah, that's really cool. That's excellent. This work is essentially making science fiction a reality, allowing people to burn less energy while conducting a variety of tasks, Sue said. Yeah, so easier to train exoskeletons could lower barriers for people living with disabilities. Now, recovery too. I mean, you have somebody that's had hip replacement surgery. You got to get back on your feet. You got to exercise. You got to, all this sort of stuff. But very difficult to exercise when they won't let you go into a swimming pool because for legal reasons, or a gym for legal reasons. And it's dangerous for you to walk because your leg might go out from underneath you or something like that. But unless you get exercise, your muscles aren't going to expand. Dear oh dear. Your muscles aren't going to gain any real world strength. So, this could be really, really good, for helping people get out, get that light exercise they need to get the strength back in their while their body's adapting to having, in my case, an artificial hip. Now, through the real-world experiments with the simulation trained devices were carried out by participants without physical disabilities. Researchers say the findings could meaningfully help people who live with a wide variety of mobility challenges, from stroke survivors to people with limb differences to individuals living with neurological conditions like cerebral palsy. It's been 12 months since my hip replacement, and I would like to put my hand up to, if anyone's watching, for this experiment. It would be absolutely awesome. I would definitely volunteer without any hesitation, because I need all the assistance I can get, and if it means that I can walk properly without a walking stick, because I do have a little walking cane, I would absolutely love that. I don't need miracles. I don't need to be climbing Mount Everest or running in marathons. I just would like to be able to, gain my, some sort of resemblance of normality, or semblance, whatever the word is. Mum, get a refund from the Catholic school. Don't even know what words are. All those school fees gone to waste. And while this particular experiment focused on a hip exoskeleton controller, the same basic learning framework could be applied to knee and ankle exoskeletons as well. Aside from cutting down on training times, the virtual simulation methods mean exoskeleton designers could also, theoretically, have finger spasms and not be able to highlight the text properly. Theoretically send out updates to devices with improvements. Now, down the road, researchers imagine this updatable system could aid in the development of highly customized controllers fine-tuned to an individual wearer's needs. Yes, definitely. Please get this system to run on Linux, because you wouldn't want to be walking down a road or climbing a ladder or doing something and it does a Windows update, and the next thing you know, I'm sorry, I have to reboot your exoskeleton. No, make it Linux. Thank you very much. I appreciate that. And that way it can be updated on the fly. Yep, so our approach marks a significant advancement in wearable robotics. New Jersey Institute of Technology Biodynamics Lab Director and paper co-author Jianlian Zhu said in a statement. Now, this hip controller seamlessly transitions to hardware without requiring further human subject testing, rendering it experiment-free. Well, that is absolutely amazing. I think that is so cool. I mean, just the fact that we've reached this level of technology, having an exoskeleton that can learn, has a base level of learning already built into it, and then, jump into the darn thing, and then it starts to learn about you and how you do things and goes, Jesus Christ, you fat bastard, what are you doing? But yeah, that would be incredible. And as I say, put my hand up, love to volunteer. It'd be absolutely fantastic. All right, well, my name is David. Thanks for joining me for another Studio 64 Science, Space and Tech News update. I shall see you in the next one. If you enjoyed this video, please like, share, subscribe. I'd greatly appreciate it. If you're up for it, drop a comment down below the video, because I'd love to hear what you think. All right, take care, and as I always say, if you can't be good at it. And as I also always say,
my brain hurts!